might be where you're getting confused, maybe. So when I multiply by everything, because I'm going to cancel it out. And then I'm just left with 3x plus 1. So the denominator's gone.
Okay, so the denominator is gone after that point.
Right.
Oh.
Okay, so when we in the ones we just done, it stayed there.
Okay.
So that's why I multiply by the whole thing. And I understand what you said, and that is not wrong, because that's what we end up with when I cancel them. But I want you to realize the reason you're canceling out those denominators is because you multiplied through by a common denominator.
Okay, so what if I do keep the denominators in it though? I mean, you're going to subtract it, so it's going to cancel out on the bottom there, but in the equals it still has it.
Mm-hmm.
So,
well, it really doesn't. It wouldn't go away. It'd still be under there, and it would be wrong.
so why don't you multiply the bottom, or why don't you put x plus 1 on the bottom whenever you multiply, like the first one?
Okay, I understand what you're saying. Okay. Well, we're just adding and subtracting. We're trying to make this, say this one, to equal what my common denominator is.
Mm-hmm.
But because I have an equals mark, that's the key there. Like when we had that fraction a while ago, I multiplied through by a common denominator, it made all those denominators go away.
Mm-hmm.
When you have an equals and you multiply through by a common denominator, all the fractions go away.
So in other words, you're trying to get the denominator gone whenever you have an equals mark.
Right.
Okay.
So then now we can solve. 3x plus 3 minus 4x plus 8 equals 5. And then negative 4x plus 11 equals 5. 3x. Remember to always distribute the negative, and that negative goes all the way over to the 8. That's a common mistake. So make sure you do that. And we have
plus 6.
negative x
Yeah.
plus second. So negative 11, so we have negative x plus equals 6, and so x would be negative 6.
What do you mean, negative 6? Because you subtracted 11? 5 minus
No, that's right, it's a negative, yes it is. So you're a positive. And you are Johnny on the spot, buddy. You're going to say, I'm glad I wasn't in your class, Miss Brown. You make too many mistakes.
So when you divide by negative 1,
That makes that a positive, yes. And with these, one thing you have to be careful of, and I don't know if it says, yes it does, it says, solve the following equations involving rational expressions. Be sure to check your answers in the original equation if you multiply both sides by the expression that contains a variable. So we did, this contained a variable. So we want to, and basically all you really have to check is the denominators. So the 6 would not make any of these 0.
So there would be no solution?
No, 6 would be the answer.
Okay.
So let's say, for example, this turned out to be x equals 2.
Okay.
2 can't be an answer because it's going to make that 0, which makes it undefined. Okay. So. All right. So now you see the difference?
Yes, ma'am.
Okay, good. In chapter 7, we did have, well, we'll get to the word problems. Let's do the other complex fractions and then ratios, and then we'll come back to the word problems. The complex fractions. Let's look at how about like number 19? And really with complex fractions, you're almost doing the exact same thing we did here, because you're multiplying through by a common denominator to get rid of that complex fraction. But I've seen, I saw on some turned in that some students do them totally different than how I would have taught it in class. So how did you go about doing that?
I honestly could not tell you. I do not remember.
Hey, you're honest anyway. If you look here, we look at the denominator here, and the denominator here. And so since x squared would be a common denominator,
Okay.
we multiply every term by x squared. So we do this by x squared, that by x squared, this by x squared, that by x squared, and that by x squared. That's how I would do it.
Okay.
And so we would end up with x squared, these cancel, minus 16 over x squared minus 2x, because my x is kind of, we subtract them.
No, there's usually one.
One,
Okay.
right. And then my x squares go away, and I'm left with minus 8.
Okay.
So now that looks a heck of a lot better, doesn't it?
Mm-hmm.
And now we would factor.
Okay. So x plus 4, x minus 4.
Okay. Over
X plus 4, x minus 2. No, x minus 4.
Right. Because you have a negative. Right. Okay. And then you can cancel those. And we're left with x plus 4 over x plus 2.
Okay.
So basically you want to look and find the common denominator and multiply by it. Let's look at another one. Okay. Ratios. If you had, when you talk about ratios, like number, say, 16.
Okay.
But that's kind of... Well, 20. If it says the solution of alcohol